Okay, this is a probability table. It's something else that really shows up very standard in probability problems. Now, the problem people have with interpreting the questions is where do they get the denominator from? And so you just have to parse the questions really carefully. So A is pretty straightforward. What's the probability that a selected student is not 19 years old? Well, they already told us that there's a total of 45 students in the whole sample. So there's our denominator. And the number of students that are not 19 years old, well, let's just add up the number that are 19. That's 12. And 45 minus 12 gives us 33. And it looks like that can be reduced. How about the probability a female student is 20 years old? Okay, here's where we have to take a look at, we're actually only giving the probability out of the female students. So when we add up the numbers for the females, 6 and 5 is 11, plus 9 is 20, so we get a total of 22. That's our denominator. And a female student is 20 years old. Out of that row, there are 9 of them. So if we just randomly pick one of the female students, probability they're going to be 20 is 9 out of 22. Okay, this intentionally asks the same kind of question, only the other direction. What's the probability a 20-year-old student is female? Well, now we go and add up how many students are 20. So that looks like it's 17. And so the number of 20-year-old students out of the 17 that are female is 9. So there's our probability that a 20-year-old student is female. Let's make that just a little bit clearer to see. Okay, last one, a female student is under 21 years old. Well, now we're just looking at the female row, and the denominator for that, like we already figured out, was 22. A female student is under 21 years old. We know there's a total of 22 of them, and the number that is over 21, or 21 and over, is 2. So if I subtract 2 from 22, I get 20. And we're done with that problem. Okay, on to bags of marbles or boxes of candies, or same thing. Again, very typical probability problems. So we've got a bag that has 11 marbles, 4 are green, 7 are blue. And they're asking for probabilities in a very straightforward way. If they ask for a probability of B of G, and we need to figure out if we're replacing. Okay, without replacing the first marble. So the probability of B of G is the probability of selecting a blue marble and then a green marble without replacement. So, and that's exactly what they're asking us to do on the first one. So the probability of picking a blue marble first out of the full bag is 7 out of 11. They tell us there's 7 blue marbles. Now, what happens is all 4 greens still stay in there, but the total number of marbles goes down by 1. So the probability of picking a blue and then a green is, the probability of picking the green after the blue's been picked is 4 out of 10. And looks like we get 14 out of 55. Okay, probability of picking a blue and a blue. All right, well, there are 7 out of 11, back to a full bag of marbles. And if the first one we pick is a blue, then both the number of blues and the number of marbles goes down. So the second blue is going to be 6 out of 10. And that looks like it's 21 out of 55. Probability of picking a green and then a green. Same idea, only now we're working with the 4 greens. So 4 out of 11. And then the green and the number of marbles goes down by 1. 3 out of 10. That looks like it's 12 out of 110. Oh, 6 out of 55. And the probability of picking a green and then a blue. So full bag, number of greens 4 out of 11, and we still have the 7 blues that we started with, but the number of marbles went down. And done with that problem. I'm going to press on because this is the last example. And same kind of arrangement, except for now we have 3 colors. And we also replace it. Okay, so we pull the marble out and throw it back in. So probably picking a red and then a green. Well, there's 5 out of the 12 that are red. We pick that red, we throw it back in, and we still have 12 marbles. The probability of picking a green is 4 out of 12. And I'll spare you the reducing. I got 5 out of 36. Probability of a blue and then a blue. Well, we have 3 blues to start with out of 12. And we pull out that blue, we throw it back in, and now we still have 3 out of 12. And that's going to reduce to 1 out of 16. Green, blue, 4 out of 12. And the number of blues is 3 out of 12. So 3 times 4 is 12. Looks like that will reduce to 1/12. P, not red, not red. Okay, now I've played around with a few formulas, but really what we're doing is if we're not picking a red, we're going to be looking at the probability of picking either a green or a blue. So the probability of picking not red, so there's 4 green, there's 3 blue. That would be 7 out of 12. And whatever color we pick, green or blue, we throw it back in. And we still have the probability 7 out of 12, 49 out of 144. And we're done with this lesson. I will see you in class.